This is section 5.2, verifying trigonometric identities. And this is a one-part lesson, just as yesterday's was. Now, these are some guidelines for verifying identities. And if you want to put it in simpler terms, verifying a trigonometric identity is just proving that one side equals the other. After all, an identity is really just an equation. And so verifying a trigonometric identity is just showing that the left side equals the right side, or that the right side equals the left side. So that's basically what we're going to try to do here. Again, this is an exercise in analytical trig, which, rather than sketching triangles and determining vectors, has to do more with manipulating identities. Alright, so the first thing is you start with the most complicated side of the equation. Now, it's not always easy to determine which is the most complicated side, but sometimes it is. And when it's a toss-up, you can just go with one, whichever one you like. Alright, but in general, if there is a more complicated side, start with that one. Factor expressions add fractions, square binomials, or create monomial denominators if possible. Now, all this is going to become clear when we see the examples in the following screens, but for now you should be writing each of these steps down, because these will help you the first times that you verify trig identities. Step 3, use the fundamental identities whenever possible. So the identities are your friend. You're going to be using those a lot in this section and next. If none of the above work, convert all terms to sines and cosines. Remember that you can always put a trig function in terms of sine and cosine. Tangent, cotangent, secant, cosecant, they all relate to sine and cosine. And the fifth step, which seems obvious, is always try something. Now, the reason that this step is important is that sometimes you really don't know where you're going until you finish, but if you just keep trying steps 1 through 4, you will make some progress. Alright, let's look at our first example of verifying a trigonometric identity. Secant squared theta minus 1 over secant squared theta equals sine squared theta. Now in this case it's obvious which side of the equation, the identity, is more complicated, and the left side here is the more complicated side of the equation. So we're going to start with that, and what we want to do is show step by step that the left side does in fact equal the right side. So first step, secant squared theta minus 1 over secant squared theta equals tan squared theta plus 1 minus 1 over secant squared theta. Now why is that true? Because if you look at your Pythagorean identities, you'll see that there are 3, and one of them is sine squared theta plus cosine squared theta equals 1. Another one is 1 plus cotangent squared theta equals cosecant squared theta. And another one is 1 plus tangent squared theta equals secant squared theta. And that's why we replace the secant squared theta with tangent squared theta plus 1. Now simplifying, plus 1 minus 1 is just 0, so it disappears. So we have tan squared theta over secant squared theta. And then we can rewrite secant squared theta as cosine squared theta, simply because if the cosine of theta is equal to 1 over the secant of theta, just as the secant of theta is equal to 1 over the cosine, well then secant squared theta must be the same as cosine squared theta. Now we write the tangent in terms of sine and cosine, so tangent squared theta is the same as sine squared theta over cosine squared theta. And now we can cancel, and as you can see we end up with simply sine squared theta, and that indeed is the right hand side of the original identity. Next example, verify the identity tan squared theta plus 1 times cosine squared theta minus 1 equals negative tan squared theta. Again, it's obvious which side is more complicated. The left side is more complicated. So let's work with that first. Tan squared theta plus 1 times cosine squared theta minus 1 equals secant squared theta times negative sine squared theta. Now let's see why this is true. If we look just at tan squared theta plus 1, we can see that that's the Pythagorean identity, 1 plus tangent squared theta equals secant squared theta. And so that's why we replace the tan squared theta plus 1 with secant squared theta. Also, simultaneously, what we did in this step is we looked at the next term, cosine squared theta minus 1. And that should definitely remind you of the first Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. And when you rewrite that, of course, it turns out that sine squared theta is 1 minus cosine squared theta. And when you take the negative of that, you get cosine squared theta minus 1. And that's why we end up with negative sine squared theta as the replacement for cosine squared theta minus 1. And now we can set this equal to negative sine squared theta over cosine squared theta, because similar to the way we did in the last example, secant squared theta is the same as 1 over cosine squared theta. And so we have rewritten it, and we have negative sine squared theta over cosine squared theta. And that, of course, is the same as negative sine theta over cosine theta squared. Many of you wouldn't even need this step because you can, see that sine over cosine is simply tangent. But I just put this in to make it extra clear. And finally, since sine theta over cosine theta is tan theta, we end up with negative tan squared theta. And that is what we set out to show was equivalent to the left-hand side. And so we've now proven that the left-hand side of this identity does in fact equal the right-hand side. Another example, verify the identity tan x plus cot x equals sec x times cosecant x. Alright, so this is one of those cases where it's not 100% obvious which side is more complicated. But a good rule of thumb is when there are more terms, it's more complicated. Alright, that's not always the case, but in this case, since the left-hand side has more terms, we're going to try to manipulate that left-hand side first. So the first step then is sine x over cosine x plus cosine x over sine x. Tangent x is simply sine x over cosine x by the quotient identity. Cotangent x is simply cosine x over sine x by the quotient identity. Alright, so this is the first step in this verification. You should pause the video now, try to do the rest on your own, and then resume once you have something that is equivalent to the right-hand side. Continuing now with the solution, the first thing we want to do is put them together with a common denominator. And so the common denominator is cosine x sine x. And to get that common denominator, we simply multiply that first term by sine x over sine x, and we multiply the second term by cosine x over cosine x. And we end up with sine squared x plus cosine squared x over sine x cosine x. Next step, using the Pythagorean identity. Since sine squared x plus cosine squared x is 1, we replace it. And we have 1 over sine x cosine x. Now we can rewrite that further as 1 over sine x times 1 over cosine x, because it's mathematically equivalent, because the numerator is just 1 times 1, and you just end up with 1. So all we're doing is splitting it for the sake of the next step, the final step, which is showing that indeed 1 over sine x is cosecant x, 1 over cosine x is secant x, and that matches the right-hand side of the original identity that we were verifying. Next example, verify the identity cotangent to the 4th power x times cosecant x equals cotangent squared x times the quantity cosecant cubed x minus cosecant x. Alright, so this is one of those cases where it's hard to tell which side is more complicated, so you could pretty much take your pick. Let's go with the left side. Let's go with the left side. You want to try to isolate the left side and manipulate it until you end up with something that resembles the right side. So the first step then is to break up cotangent x to the fourth power into cotangent squared x times cotangent squared x, since it's the same thing. Alright, so at this point you should pause the video, try to do the rest on your own, and then resume when you have an answer. Okay, going through the solution now, we can replace that middle cotangent squared x with cosecant squared x minus 1. And we simply get that from the Pythagorean identity of 1 plus cotangent squared x equals cosecant squared x. Therefore, cotangent squared x equals cosecant squared x minus 1. So we replace that middle cotangent squared x with cosecant squared x minus 1. The next step is that we can distribute those last two terms, and we end up with cotangent squared x times cosecant cubed x minus cosecant x. We simply distributed, with that parentheses, we distributed the cosecant x to end up with the right-hand side of the original identity. Here's the classwork, page 387. Please write these numbers down. And just a bit of a heads up regarding this classwork. Although what you're trying to do is kind of simple, you're just trying to show that one side equals the other. Students sometimes get confused with these. It's not easy, and it is a different skill and trick. It's because it's analytical trick. So just be prepared to consult your trig identities a lot. Make sure that you have those all written on one page. And see you in class.